Okay guys, this is called building polynomials. We've done this before with building quadratics, but we're going to do it with polynomials. So we are going to pull together everything we've been learning for the past few weeks and build a polynomial. Okay? So we're going to start with number 1, which yours is labeled number 1, and I'm going to show you how to do this one, and then you're going to kind of work on the rest on your own, okay? And your goal is to get through the first 4. If you get further, that's great, but your goal is to get through 1 through 4 by Monday. Okay. So the first thing you have on the left is you have your roots. Now, multiplicities is how many times you have that root. So we have 1 root at 5, we have 1 root at 2, and we have 2 roots at -3. The degree is what's the highest exponent? We don't know yet. The plus or minus says what the leading coefficient is. So this is a positive leading coefficient. Okay, so we're going to start with factors. You're going to write x. You're either going to write plus or minus. Well, if x equals 5, then the factor was x minus 5. Then if the factor is x equals 2, it would be x minus 2. Now, and then you're going to have x plus 3. And you're going to have 2 of those, so I'm going to write it twice. Okay, now you're going to multiply these together to figure out what the standard form of the polynomial is. Once we know our standard form, that'll tell us our end behavior, which will help us sketch, will help us find the y-intercept over here. So, here we go. We're going to multiply 2 at a time. So I'm going to multiply this one and this one together. Okay? So I'm doing x minus 5 times x minus 2 first. And you can write them all out up here if you want to. We're going to multiply them all together, but you only do 2 at a time. So I'm going to focus on these 2. So first, outside, inside, last, you're going to get x squared minus 2x minus 5x plus 10. And then I'm going to put those in parentheses. And then I'm going to add my like terms to get x squared minus 7x plus 10. Okay, now I'm going to then multiply these 2 together, because you can do it 2 at a time and multiply these 2 together. And I'm going to FOIL. First, outside, inside, last. You're going to get x squared plus 3x plus 3x plus 9. Add my like terms, and I have x squared plus 6x plus 9. Okay, now I'm going to multiply this one times this one. Okay, so I did these 2, did these 2, simplified those, now I can multiply these 2 together. Okay, so you could FOIL these, but this is where the box method is probably going to be. It's a little bit more helpful. So let's say this first polynomial might go down with, so x squared, negative 7x, and positive 10. And you may want a different piece of paper, that's totally fine. X squared, 6x, and positive 9. So you're going to multiply them, and then we're going to add our like terms, and we're going to figure out what our polynomial is. So x squared times x squared, that would be x to the 4th, you add the exponents. X squared times 6x would be 6x cubed. 9 times x squared would be 9x squared. Negative 7 times x squared would be a negative 7x cubed, you're adding the exponents. Negative 7 times 6 is negative 42, x squared. 9 times negative 7 is negative 63x. 10 times x squared is 10x squared. 10 times 6 is 60x, and 10 times 9 is 90. And of course, if I'm going too fast, just have this pause the video, or you can pause the video. Okay, so we're just going to add our like terms in here. This is part of the problem, so these are not part of my answer. X to the 4th is by itself, so I'm going to write x to the 4th. Add these, and I get negative 1x cubed, so I'm going to write negative x cubed. Add these together, so 10 plus negative 42 plus 9 is going to give me a negative 23x squared. Then I have positive 60x plus a negative 63 is a negative 3x plus 90. Okay, so this is my polynomial. I can go back over here and say my degree is the 4th degree. Okay, so it's a cubic, or quartic. You could write quartic if you want to, I don't care. In behavior. Okay, well, your leading coefficient is 1, and it's positive, so that's good. If this was negative, I'd multiply it all by a negative. So we have a positive leading coefficient, an even degree, which means the ends are both going to be up. And then your y-intercept, well, of course, it's just the number at the end, which is 90. And then we're going to sketch. So I'm going to draw an x and y axis, and this is not going to be perfect. It's not going to be to scale, but we're just going to do our best. So let's see. I know my root, so I can plot a positive 5. I can plot positive 2, and I can plot negative 3. And it hits there twice, so technically there's 2 dots there, but we'll talk about that in a sec. And then positive 90, I'm just going to sketch it up here. I'm going to estimate. Okay, so you can plug it in your calculator to check once we've done this, but the left-hand side's up, and you only cross the x-axis where you have roots. So I'm going to go down, and I'm going to cross at negative 3. Now, if I only had one negative 3, I'd go straight through, and then I'd have to come back up through an x-intercept. But because this one bounces, that's what a multiplicity of 2 means. It means instead of going through, it's going to hit, and it's going to bounce back up. And it's going to go up to 90, because it can only cross an axis where you have a perfect point, so it's going to cross at 90. It's going to go back down, and it's going to go through the positive 2. And I know this because there's only one time it hits there. Then I'm going to go down a little bit, and then I'm going to come back up through that point. So you can only cross the x or the y-axis through a perfect point, which would be a root or a y-intercept. Now, go ahead and plug this in your calculator, and you can check your answers. Make sure it hits at 5, 2, it bounces at negative 3, and then it crosses at 90. You may have to mess with your window a little bit to figure out what it looks like. I'm not looking for perfection here. I'm looking that you went through the points that we found on this problem. Okay? So you can watch this video as much as you want, but that's how you do it. So when you look, and I'm just going to give you helpful hints for each of them. Okay, that's all. I'm not going to do the whole problem for the rest of them. It's the only one I'm probably going to do. So let's see. On number 2, you're going to have a root at 4, a root at negative 3, and a root at 1, and a root at 0. These ones just mean you only have one of them. So when you write your factors out, it's going to be x minus 4, x plus 3, x minus 1, and then this x equals 0, that's just an x. Okay? So x is a factor. So when you write out all 4, you're only going to multiply 2 at a time. Okay, that's all I'm going to give you for that one. Okay, so let's look at number 3. Okay, so on number 3, instead of giving you the roots, I gave you the factors. So set this equal to 0 and solve to find all the roots. Now, because none of them are repeated, you're just going to have one of each of them. And when you do standard form and you write all these out, you can only multiply 2 at a time. So I would multiply these two, get the trinomial, multiply it by this one, and you'll get a big long polynomial. Then you'll be able to do everything else. This is similar to number 1. And it's going to be positive. Look at number 4. If I've given you the polynomial, you're going to go backwards, and you're going to find everything. So this is the polynomial. You want to factor this. So I'm going to give you a helpful hint right here. To factor this, you are going to take out what they all three have in common. So I can divide them by a 2 and an x squared. So you're going to divide by 2x squared. And you see how this is a 4? I already know what my degree is, 4. And I also know that I should have 4 roots. If this is a 4, I should have 4 roots. If you take out the 2x squared, you're going to be left with x squared minus 3x minus 10. And you can factor this. Add to get the middle number, multiply to get the number at the end. I'm not telling you what the factors are. And this section right here, whatever this is, whatever goes right here, those are your factors. And your roots, of course, you're going to set this one equals 0, you're going to set this one equals 0. For the other two, it comes from 2x squared. So this is kind of weird, but you would take 2x squared, set that equal to 0, divide by 2, divide by 2, x squared equals 0, square root both sides, and x equals plus or minus 0. So for roots, you have 0, and you actually have a multiplicity of 2. Okay? And that's weird because you can only have a positive 0. Just trust me, we'll talk about it when I come back. But this is saying that you'll have 0 2 times. Then you'll have some number here, which will give you a root, some number here, which will give you a root. You should be able to get figured out. Okay, you can always use the people around you to help. If you decide to start number 5, this is number 5, you get to pick. So you'll see that you have to have a negative leading coefficient. You have to have a root at 6 and a root at negative 3, but you can have multiple ones. So you could choose 2 and 2, 1 and 3, 3 and 1, whatever you want. So this is going to have multiple answers. So if you're working with somebody, you probably should pick the same one. That way you can work on it. If you try number 6, just be careful the y-intercept is 80. So when you go through this whole thing, you may have to multiply by a number in order to make it have a y-intercept of 5. Just make it have a common term. Okay? Good luck. I will see you on Monday, and we will go over these, but your goal is to get through number 1 through 4. If you get more done, that's great, but make sure you're asking for help. The sub will have an answer key, but I will see you on Monday.